Hello everyone, I'm Dr. Dro and welcome to my channel. In the video today we're gonna talk about class attributes versus instance attributes in Python. When they share the same name, this can be very confusing and cause a lot of troubles. Something that occurred to me in a recent project, and someone who wasn't so familiar with Python had these problems, and it took a while to figure out where we were failing. So in the example I prepared for you, which is inspired by a Stack Overflow question, I will demonstrate the details and the differences between class attributes and instance attributes. So let's jump right at it in the code here. As I mentioned, it's inspired by this Stack Overflow question. I will put a link in the description. And we will walk through this example in 3 phases. We start with this very basic class definition where we have here the class attribute name. It's initialized with the value someName, and the initialization function has one parameter name, and we assign it to the instance variable name. We also try to append this input to self.tricks, and the way Python is going to treat this, it will first try to assign it append name to an instance attribute. If it fails to do that, it will try to do this to a class attribute, and if it fails to do that, we will get some error. Let's see how it works in practice. I also look here at this foo.tricks. Let's check what's the idea of this, and I hope it's not a big surprise. We get an attribute error here because foo, the class, doesn't have the attribute tricks, so there's no ID for this object. Furthermore, if we try to initialize f1 with this input hello world, we also get an attribute error, and the reason is, again, as I said before, Python first tries to append the name, the input, to an instance attribute. It fails to do that. It tries to do this to the class attribute. Fails to do that as well, hence the attribute error. Let's clear everything, restart the kernel, and change the definition of foo a little bit. Here we instantiate also tricks to be the empty list, and note here it's still a class attribute. Otherwise, I didn't change anything. We can evaluate this. Now, foo.tricks returns an ID. It's the ID of the empty list that's assigned to foo.tricks. We can now also instantiate f1 and look at the values that we get. f1.name, no surprise, it's hello world. f1.tricks is the list with one value, hello world. And the ID of f1 tricks is exactly the same as the ID of foo.tricks, and this is exactly what should make you start feeling what's gonna happen next. When we try to instantiate f2, then f2.name is byworld, and that's where things get hairier a little bit. f2.tricks, we have hello world from before, and also byworld. And the reason is, still, it's a class instance, it's the same ID. So it's an attribute shared by all classes that instantiate objects inheriting from foo. We can see that even f1.tricks got changed here, because again, it's the same object under the hood. We can see it by looking at the IDs of foo.tricks, f1.tricks, and f2.tricks. Now we're getting to the last step of this demonstration. We restart everything and we uncomment this part where we instantiate an empty list as an instance attribute, tricks. This works fine. Foo.tricks still works, right, with some ID. And we can instantiate f1, and note here that f1.tricks has a different ID compared to foo.tricks, right? If we now go for f2, we see that f2.tricks is a list with a single variable where it's instantiated during the creation or the initialization of f2, and it's a new empty list, so it has nothing to do with f1.tricks, and we see it by the ID. It's a third ID. If we check what happened with f1, then f1 didn't change. f1.tricks is still a list with a single value, hello world. We can also check it here and see, just to recap, foo.tricks has one ID, f1.tricks has a different ID, and lastly f2.tricks has yet a third ID, so they are independent one of the other. To recap, class attributes are shared among all instances of the class. It can be used, I'm not going into the use cases. For example, if you want to persist some state that's shared across all instances of some class, this is a way to go. But in some other cases, it can be confusing and create some problems. So be careful. I hope this was helpful here for you to understand the differences. And that's it for today. I'm Dr. Dro. Don't forget to click the like button and the subscribe. And I will see you in the next video. Happy coding and take care. Bye bye.